The American continent holds one of the most extraordinary stories on Earth, a tale that stretches back billions of years. Long before cities, nations, and civilizations rose upon its soil, this vast landmass was a restless stage of shifting plates, erupting volcanoes, and rising mountains. Ancient seas once swallowed great stretches of its surface, while mighty glaciers later carved deep valleys and lakes that still shape the land today. Dinosaurs thundered across its plains, mammoths wandered its tundra, and the first peoples carried their traditions across its wide expanse, leaving echoes that endure to this day. In this video, we'll uncover the history of the American continent as well as the unfolding of life, culture, and the forces that continue to shape its destiny. Before we begin, tell us in the comment section below where in the world you're watching from and what time it is there now, so settle in and enjoy a journey back in time. Hundreds of millions of years ago, the continents of the world were not separated as they are today. Instead, they were joined together into supercontinents, vast single land masses surrounded by endless oceans. The earliest of these, known as Rodinia, came together over 1 billion years in the past. Within Rodinia, the building blocks of what would later become the Americas were already present, bound to other pieces of land in configurations that looked nothing like today's map. The rocks that form much of North America's ancient heart, called the Canadian Shield, are among the oldest found anywhere on Earth, with ages stretching back nearly 4 billion years. These rocks tell us that the foundation of the American landmass is as ancient as the earliest chapters of Earth's history itself. As time marched on, Rodinia eventually broke apart, scattering its pieces into new arrangements. Around 550 million years ago, another great supercontinent called Gondwana began to take shape in the southern hemisphere. South America was a part of this southern giant, while North America drifted elsewhere, tied to other landmasses. The Earth's surface was never still, and the continents drifted like slow ships carried by the currents of plate tectonics. Eventually, another supercontinent called Pangaea emerged around 300 million years ago, when nearly all of Earth's land rejoined into one massive body. Within Pangaea, North America and South America were fused alongside Africa and Europe, forming a vast connected landscape where dinosaurs would one day roam. The slow breakup of Pangaea was the event that truly began to shape the Americas as we know them today. Around 200 million years ago, deep rifts opened in the crust as the plates stretched and tore apart. Magma rose from below, creating new ocean floors and pushing continents further away from each other. It was during this time that the Atlantic Ocean was born, widening over millions of years and gradually separating the Americas from Europe and Africa. This process was far from quick. On average, continents drift only a few centimeters each year, but over millions of years these small movements carve out entire oceans. North America took shape first as its craton, the ancient stable block of crust, gathered smaller fragments of land known as terranes. These terranes were once islands or pieces of other continents, carried by drifting tectonic plates and slammed against the growing continent like puzzle pieces being pressed into place. The western edge of North America, now home to the towering Rocky Mountains, was built up by countless collisions of these drifting fragments. Each time a terrain was added, mountains rose, volcanoes erupted, and new landscapes were formed. Over millions of years, the landmass grew wider and more complex, until it stretched from the icy Arctic regions to the warm Gulf of Mexico. South America's journey was equally dramatic. For much of its early history, it remained joined with Africa as part of the massive land of Gondwana. Around 130 million years ago, cracks began to split Gondwana apart. Slowly, the South Atlantic Ocean opened, and South America drifted westward, away from Africa, carrying with it unique plants and animals that would evolve in isolation. The Andes Mountains, one of the most striking features of the continent today, rose as the oceanic Nazca Plate was forced beneath the South American plate, pushing the land upward in a long jagged spine that still grows taller each year. The meeting point of North and South America was one of the final pieces of the continental puzzle. For tens of millions of years, the two continents were separated by a wide seaway, with North America drifting westward while South America moved north. Finally, around 3 million years ago, the Isthmus of Panama rose from the sea, a narrow bridge of land linking the continents together. This event was one of the most important in Earth's recent history because it allowed animals and humans to migrate between the two vast landmasses. Jaguars, llamas, mastodons, and even early humans crossed this land bridge, changing the course of life across the continent forever. The birth of the Americas is not a finished story. Even today, the tectonic plates continue to move beneath the land. Along the Pacific coast, the grinding boundary between the North American and Pacific plates creates powerful earthquakes and volcanic eruptions. The San Andreas Fault in California marks a scar where these two plates slide past one another, shifting the landscape in sudden, violent bursts. In the south, the Nazca Plate continues to dive beneath South America, lifting the Andes ever higher and fueling volcanic activity. The Caribbean, Central America, and even the eastern seaboard of the United States all bear marks of this constant movement, reminding us that the forces that gave birth to the continents are still alive beneath our feet. From the ancient bedrock of the Canadian Shield to the soaring peaks of the Andes, from the wide plains of the Midwest to the jungles of the Amazon, every part of the American continents carries the memory of this long journey. Each mountain range, each coastline, and each valley is a record of tectonic power, written not in ink but in stone. What we call the Americas today is the result of billions of years of collisions, separations, and transformations, an epic saga still unfolding as the Earth's restless plates continue their eternal dance beneath the surface. In the earliest days of our planet, more than 4 billion years ago, the first stable pieces of land began to form as molten rock cooled and hardened. These ancient fragments, called cratons, became the heart of continents. In North America, the Canadian Shield is one of the most enduring of these ancient survivors, stretching across much of Canada and parts of the northern United States. Its rocks are so old that they record some of the earliest chapters of Earth's story. Long before forests, before animals, even before the first complex life, molten seas and volcanic landscapes cooled into the hard granite that would one day hold the foundations of mountains and valleys. When we look upon those ancient rocks today, we are peering into a world unimaginably distant, where continents were only just beginning to take shape. The earliest supercontinents gathered these cratons together. More than 1 billion years ago, the pieces of land now scattered across the world were united in a vast body known as Rodinia. At that time, the pieces that would later become the Americas were bound to other landmasses in strange positions, the shapes and outlines of modern continents unrecognizable. The future North America may have been pressed against Australia and Antarctica, while South America sat tied to Africa, their boundaries blurred in one endless chain of land. The air then was thick with different gases, the seas swarming with early forms of life that bore little resemblance to the creatures of today. But even in those times, the slow drift of tectonic plates was already at work, breaking Rodinia apart, scattering pieces across the globe, and setting the stage for new supercontinents to come. One of the most important chapters unfolded hundreds of millions of years later when another great gathering of continents formed the supercontinent Pangaea. Around 300 million years ago, nearly all of Earth's land fused together once more. Within Pangaea, the Americas were part of an immense connected world where deserts stretched for thousands of miles and great inland seas lay trapped between mountain chains. The land teemed with strange forests of towering ferns and conifers, while giant insects buzzed through the air and the ancestors of reptiles roamed the ground. In time, the dinosaurs appeared, walking across the joined continents with ease, leaving behind footprints that would one day be found in stone. For tens of millions of years, Pangaea was a place where animals and plants could spread across almost the entire Earth, but the forces beneath the crust were not still, and cracks began to tear this mighty landmass apart. The birth of the Atlantic Ocean marked a turning point in the story of the Americas. Around 200 million years ago, the plates beneath Pangaea began to stretch and rift, splitting the supercontinent into smaller fragments. Lava welled up through long cracks, hardening into new ocean floor, while water from the seas rushed in to fill the widening gaps. As this process continued over tens of millions of years, the Americas began to drift away from Africa and Europe. South America carried its forests and creatures westward, while North America moved northwest, gradually taking the positions they hold today. At first, the ocean between them and Africa was narrow, but each passing year widened it by just a few centimeters, until over vast spans of time the Atlantic became the broad ocean we know. The building of the Americas did not stop with drifting apart. Their edges were shaped by the arrival of smaller land fragments, carried by the restless plates like rafts across a fiery sea. Along the western edge of North America, tiny islands and terrains, pieces of crust broken from elsewhere, were pushed against the continent, sticking to its side like puzzle pieces. Each collision lifted mountains, formed new coastlines, and changed the shape of the land. The mighty Rocky Mountains, stretching across thousands of miles, were raised through these endless clashes, layer by layer, fold by fold, until their snow-capped peaks rose high above the plains. Fossils found in their rocks tell stories of ancient seas that once covered the land, of strange reptiles swimming where now only stone remains. South America, meanwhile, experienced its own fiery transformation. For hundreds of millions of years it remained joined with Africa as part of Gondwana, the southern supercontinent. But around 130 million years ago, the land began to crack, and the South Atlantic Ocean slowly opened. As South America drifted westward, the ocean widened behind it, leaving Africa far behind. Along its western edge, the Nazca Plate pressed beneath the South American plate, forcing the land upward into the Andes, a jagged spine of rock that still rises today. Volcanic eruptions reshaped the land, while glaciers carved peaks and valleys in later ages. Fossils preserved in the high Andes reveal seashells and marine creatures that once lived in shallow oceans, proof that land now towering into the sky was once beneath the waves. The land bridge between North and South America was one of the last great pieces of this geological puzzle to fall into place. For tens of millions of years, a broad seaway separated the continents, and ocean currents flowed freely between the Atlantic and the Pacific. Around 3 million years ago, tectonic uplift and volcanic activity raised the Isthmus of Panama from the sea, creating a narrow strip of land that forever joined the continents. This event had astonishing consequences for life. Animals that had been separated for tens of millions of years suddenly had a bridge to cross. Armadillos, opossums, and porcupines travelled north, while bears, cats, and horses moved south. This exchange, known as the Great American Biotic Interchange, filled the land with new species, altering ecosystems across the continent. Even humans would one day follow this bridge, spreading their cultures and civilizations from one land to the other. The fossils buried in the soils and rocks of the Americas tell these stories in vivid detail. In the western deserts of the United States, dinosaur bones lie scattered in beds of stone, reminders of a time when vast herds of hadrosaurs and horned ceratopsians roamed beneath towering conifers. Tracks preserved in Utah show where giant sauropods once walked in herds across muddy plains. In Canada, the Burgess Shale holds creatures even older, dating back more than 500 million years, revealing delicate imprints of soft-bodied animals that once lived in ancient seas. In South America, the fossil-rich beds of Patagonia contain some of the largest dinosaurs ever to walk the earth, such as Argentinosaurus, a giant that may have stretched more than 100 feet in length. Further north, the tar pits of La Brea in California preserve bones of saber-toothed cats, mammoths, and dire wolves, creatures that lived only tens of thousands of years ago just before humans spread across the land. Each fossil is a clue, a piece of evidence showing how shifting plates and changing landscapes shaped the lives of the creatures that lived upon them. The rising of mountains altered rainfall, creating deserts on one side and lush forests on the other. The opening of oceans changed the flow of currents, warming some coasts and cooling others, guiding the migrations of fish, reptiles, and later mammals. When North and South America finally joined, ocean currents were blocked, and the climate of the entire planet shifted. The Gulf Stream, carrying warm waters northward, began to flow strongly, shaping the climate of Europe and contributing to the growth of ice sheets in the northern hemisphere. Even today, the story of the Americas is not finished. Along the Pacific coast, the boundary between plates grinds and slips, causing earthquakes that shake the land without warning. Volcanoes rise where magma finds its way upward, their eruptions reshaping valleys and covering the land in ash. In the Andes, the mountains grow a little taller each year as the plates continue their struggle. Along the San Andreas Fault, the land on either side of the crack moves slowly past itself, so that millions of years from now, the shapes of California and the Pacific coastline will look entirely different. The restless energy of tectonic plates that first gave birth to the Americas continues, a reminder that continents are never truly still. The landscapes of the Americas, the snowbound peaks, the wide grasslands, the endless forests, the deserts that stretch beyond the horizon, are all the outcome of this vast history of drifting plates and rising mountains. Beneath every stone lies the memory of these ancient movements. Beneath every stone lies the memory of these ancient movements. Fossils whisper of creatures that once thrived in vanished worlds, while the very shape of the land tells of collisions and separations that lasted longer than any kingdom, longer than any species, longer even than whole ages of life. The Americas were born not in a single moment, but across billions of years of unceasing change, a story still unfolding beneath the ground on which we walk. The oldest stories lie buried in the Canadian Shield, the ancient rocky core of North America. Here the bedrock dates back nearly 4 billion years, older than most land on Earth. These rocks formed when the planet itself was young, when seas of magma cooled into hard crust and the air was filled with volcanic gases. At that time, there were no forests, no animals, not even the first fishes. Life was microscopic, clinging to shorelines and thriving in shallow seas. Yet in these lifeless landscapes, the first chapters of America's history were being written. Cratons like the Canadian Shield are the bones of continents solid and enduring, around which younger lands would gather. The same was true in South America, where the Guiana Shield and the Brazilian Shield provided equally ancient anchors that would one day be surrounded by newer crust, growing into the continent we now know. As hundreds of millions of years passed, these cratons were stitched into larger and larger bodies of land. More than 1 billion years ago, they joined with other ancient pieces to form Rodinia, a supercontinent so vast that its interior may have been dry and barren, cut off from the oceans. Within Rodinia, the future Americas were pressed against lands that are today part of Africa, Australia, and Antarctica. The climates were harsh, the air was different, and strange microbial mats clung to shorelines. Fossils from this time are scarce, but chemical traces in rocks suggest the stirrings of oxygen in the atmosphere, the breath that would one day sustain animals. Rodinia eventually broke apart, and the pieces wandered. In the southern hemisphere, another great landmass took shape, Gondwana, made up of South America, Africa, Antarctica, India, and Australia. In the north, the land that would become North America, often called Laurentia, drifted as its own great block. Seas covered much of this land, warm shallow oceans where trilobites scuttled across the seafloor, and early corals built reefs. The Burgess Shale in the Canadian Rockies preserves one of the most remarkable windows into this time. More than 500 million years ago in the Cambrian seas, soft-bodied creatures with bizarre forms thrived, anemone-like predators, worm-like scavengers, and ancestors of crabs and insects with armoured plates. Their delicate remains, preserved in black shale, show the explosion of life that came as oxygen levels rose and evolution leapt forward. This was one of the earliest great ecosystems of North America, long before the first forests or the first steps onto land. Through the Devonian period, hundreds of millions of years later, the land was still fragmented. Fish dominated the waters, some armoured in heavy scales, others sleek and fast. In what is now Pennsylvania, the remains of the first forests appeared, with towering tree-like plants that grew in swampy ground. Amphibians, newly evolved from fish with strong fins, crawled among the roots. Fossils from Greenland and eastern North America show these transitional forms, creatures with both gills and lungs, awkwardly shuffling onto land. In South America, similar swamps and rivers hosted their own ancient fishes, including lungfishes that still survive in altered form today. Plate tectonics was pulling the continents slowly toward one another, setting the stage for a new gathering of lands. By the late Paleozoic era, around 300 million years ago, the continents joined to form Pangaea, a supercontinent of extraordinary scale. The Americas were no longer separate but fused with Africa and Europe. The Appalachian Mountains of the eastern United States are the worn-down remnants of this collision, once as tall as the Himalayas but eroded over hundreds of millions of years. Vast coal swamps stretched across much of North America, laying down the carbon-rich layers that would later fuel human industry. Insects grew to giant size, some dragonflies with wingspans wider than a human arm, feeding on the thick air heavy with oxygen. Reptiles evolved in this world of dense forests, and among them were the ancestors of dinosaurs, crocodiles, and mammals. South America at this time was still part of Gondwana, fused against Africa, India, and Antarctica. When Pangaea began to break apart around 200 million years ago, the story of the Americas took on new direction. Lava flooded across rift valleys, leaving behind vast basalt plateaus. The Atlantic Ocean began to open, slowly widening as water filled the growing gulf between the drifting continents. North America slid northwest, South America drifted west, and both began to take on the outlines we now recognize. The dinosaurs flourished in this new world. In the deserts of Utah and Arizona, giant sauropods left trackways across mudflats, their massive feet pressing deep into the soft ground. Predatory allosaurs stalked them, leaving behind bones scattered in floodplains. In Argentina, one of the greatest treasures of the fossil record began to accumulate, bones of some of the largest creatures to ever walk the earth. The rocks of Patagonia preserve Argentinosaurus, a sauropod so immense it may have stretched over 100 feet in length, alongside predators like Giganotosaurus, a rival to the famous Tyrannosaurus in size. The climates of the Americas during these ages were profoundly shaped by tectonic movement. As mountains rose, they altered rainfall patterns, casting dry shadows on one side and feeding lush forests on the other. As the continents drifted closer to the poles or further toward the equator, their climates shifted with latitude. Inland seas sometimes spread across central North America, creating shallow waters filled with ammonites, mosasaurs, and plesiosaurs. The famous chalk cliffs of Kansas were once sea floors, preserving bones of marine reptiles and the delicate shells of ancient plankton. In South America, volcanic activity along the Andes created fertile soils where forests flourished, home to unique species evolving in isolation as the continent drifted westward away from Africa. The great drama of continental connection came much later, when the Isthmus of Panama rose from the sea about 3 million years ago. For tens of millions of years before that, North and South America had been separated by an ocean passage, their animals and plants evolving apart. South America hosted a unique array of creatures, many with no equivalents in the north: giant ground sloths as large as elephants, terror birds that stalked prey with hooked beaks, and armored glyptodonts, cousins of armadillos, encased in massive shells. North America, meanwhile, held its own giants: mammoths and mastodons, saber-toothed cats, horses and camels. When the land bridge formed, animals began to cross in both directions. Armadillos and opossums moved north, while horses and cats moved south. This Great American biotic interchange filled both continents with new life, but also brought fierce competition that drove some species to extinction. The fossil record of this time is rich. The tar pits of La Brea in California hold bones of saber-toothed cats with long, curved fangs, dire wolves with massive jaws, and mammoths whose curved tusks tangled as they fed. In South America, caves and riverbeds preserve the skeletons of giant sloths, some more than 20 feet tall when standing upright. Their bones show the power of their limbs, used to pull down branches, while where marks on their teeth reveal diets of tough leaves. Fossils of terror birds, some taller than a man, show powerful legs for running and heavy skulls for striking prey. These were ecosystems as dramatic as any today, filled with predators and giants, all shaped by the tectonic birth of the land that carried them. Even in the deep ice ages, the movement of plates continued to shape the land. The advance and retreat of glaciers carved valleys into the northern landscapes of Canada and the United States, leaving behind the Great Lakes, gouged by ice sheets a mile thick. In South America, glaciers descended from the Andes, carving fjords in Chile and leaving behind fields of rock and gravel. These glaciers advanced and retreated in rhythm with the cycles of Earth's orbit and tilt, but the mountains and landscapes they sculpted were possible only because tectonic plates had lifted the land high into the sky. The story continues today. Earthquakes shake the Pacific coast of the Americas, where the Pacific plate grinds against the North American plate along the San Andreas Fault. Volcanoes in the Andes erupt as the Nazca Plate plunges beneath South America. Along the Cascades in the northwest, volcanoes rise in a chain fed by subduction. These are not remnants of a past age, but living reminders that the forces that shape the Americas are still at work. In millions of years, the coastlines will shift again, mountains will rise higher, or wear down to plains, and the outlines of the continents may look entirely different. The land is alive with memory. Every canyon, every mountain chain, every fossil bed is a chapter of the same long story. from the ancient seas of the Cambrian preserved in the Burgess Shale to the titanic dinosaurs of Patagonia, from the coal swamps of Pangaea to the glaciers that carved the Great Lakes. The birth of the Americas has been a process of constant change. Plate tectonics not only gave rise to continents, but also set the conditions for climates, ecosystems, and the evolution of life itself. To walk upon the ground today is to stand upon the pages of this endless book, a book written in stone across 3 to 4 billion years of history. When Rodinia gathered its lands into a single supercontinent more than 1 billion years ago, Laurentia, the ancient core of North America, was already one of its central pieces. Later, when Rodinia broke apart and seas flooded across the land, early ecosystems flourished in shallow waters. One of the most astonishing records of this time comes from the Burgess Shale in Canada, a fossil site more than 500 million years old. The creatures preserved here are delicate and strange: anomalocarids with grasping limbs, hallucigenia with spines jutting from its back, and opabinia with 5 eyes and a long clawed snout. These fossils show the explosion of life during the Cambrian, when the ancestors of modern insects, crabs and vertebrates first appeared. The seas of ancient North America were crowded with trilobites, worm-like creatures, and early fishes, while primitive corals and sponges built reefs that sheltered smaller organisms. The shifting of plates during this age brought shallow seas across the craton, and with each flooding came new waves of evolution. As time passed into the Devonian period, forests began to appear. In eastern North America, in what is now Pennsylvania and New York, swamps grew thick with tree-sized plants, their trunks covered in spore-producing cones. Amphibians crawled through the mud, still tied to the water but already exploring land. The rocks here preserve the first true forests, places where plants reshaped the air by releasing oxygen and drawing down carbon dioxide. This changing climate cooled the world and allowed for greater diversity of animals. In South America, rivers and lakes hosted their own strange fishes, including early armored species and lungfishes capable of breathing air when waters ran low. The continent itself was locked into Gondwana, fused with Africa and Antarctica, yet already drifting slowly toward its own future. The late Paleozoic brought Pangaea, the great supercontinent that assembled nearly all land on Earth into one immense body. The Appalachians were raised during this time, their jagged peaks rivaling the Himalayas of today. Vast coal swamps spread across both North America and parts of South America, laying down thick layers of plant matter that, buried and compressed over millions of years, became coal seams. These forests were humid and hot, filled with giant ferns, horsetails, and seed ferns, while dragonflies the size of hawks flitted through the thick air. The oxygen-rich climate allowed for giant insects, while reptiles evolved tougher eggs that freed them from the need to lay eggs in water. Some of these reptiles would one day give rise to dinosaurs, others to mammals. The climate of Pangaea was extreme. Its vast size meant scorching deserts in the interior and heavy rains along coasts. Such conditions forced life to adapt in diverse and creative ways. The breakup of Pangaea around 200 million years ago set the stage for the Americas to emerge. As the Atlantic Ocean opened, North America and South America slowly drifted westward, breaking free from Africa and Europe. The rift valleys filled with water, and new shorelines spread outward as lava poured from cracks in the crust. Dinosaurs flourished in this age, filling niches across the land. In what is now Arizona, Utah, and Colorado, long-necked sauropods left trails of massive footprints across floodplains, while predators like Allosaurus stalked them. In South America, the great land of Patagonia became a cradle for giants. Fossils of Argentinosaurus show a creature so large that its backbone alone was taller than a human. Alongside it lived Giganotosaurus, a predator nearly 40 feet long with serrated teeth built for tearing flesh. The climate of this time was warm, with few ice caps, and lush forests of conifers and cycads covered the land. Among the most famous fossil beds of North America is the Hell Creek Formation in Montana, North Dakota, and South Dakota, a site that captures the very end of the age of dinosaurs around 66 million years ago. Here, rocks preserve the bones of Triceratops, with its great frilled skull and 3 horns, alongside the formidable Tyrannosaurus rex, one of the largest predators ever to walk the earth. Duck-billed hadrosaurs roamed in herds, leaving behind skin impressions that reveal scaly hides. Fossilized plants show forests of magnolias, oaks, and palms thriving in a subtropical climate. Hell Creek preserves not only bones, but also the ashes of catastrophe, the thin layer of iridium-rich clay marking the asteroid impact that ended the dinosaurs' reign. Within these rocks, we see both the abundance of life and its sudden destruction, a chapter in the continent's story shaped not only by tectonics, but by cosmic chance. Further west, in Colorado, the Florissant fossil beds preserve a different moment in time, around 34 million years ago. Here, volcanic eruptions buried a valley in layers of fine ash, preserving delicate fossils with astonishing detail. Entire leaves, insects, and fish remain pressed into stone, showing us what life looked like on a warm, high-altitude plateau. Giant redwoods once grew in the valley, their stumps still standing in stone, while winged insects, beetles, and butterflies are preserved so clearly that their veins and patterns remain visible. Mammals of this time included early horses no larger than dogs, camels, and rhinos that roamed grassy plains nearby. The climate was shifting then, cooling as ice began to gather at the poles, and the fossils show a mixture of species suited to both warmth and chill. Florissant is a window into how life responded to volcanic catastrophe and to long-term changes in climate, each detail captured by the fine ash of eruptions. In South America, the Araripe Basin of Brazil holds another treasure, the Santana Formation, dating back around 115 million years. This site is famous for its fossil fishes, many preserved with such detail that scales, fins, and even stomach contents are visible. Pterosaurs, the great flying reptiles of the skies, are found here as well, their fragile wings and crests astonishingly well preserved in limestone. Crocodile-like reptiles swam in lagoons, while turtles paddled through calm waters. The Araripe Basin tells of a lush tropical landscape filled with rivers and lakes, shaped by the early opening of the South Atlantic as South America drifted from Africa. The climate here was warm and wet, supporting forests of cycads and conifers. This site shows how new ecosystems flourished in the wake of continental drift, as fresh waterways and coastlines created habitats for creatures of every size. Climate itself has always been tied to tectonics. When mountains rise, they block rain and create deserts. When continents drift toward poles, glaciers advance. When oceans open or close, currents shift and carry warmth to new coasts. The Americas have been sculpted by these patterns again and again. The rise of the Rockies changed rainfall across North America, drying the Great Plains and creating vast grasslands where bison and antelope would one day roam. The rise of the Andes altered winds and rivers, creating the Amazon Basin, one of the richest ecosystems on Earth. The closing of the seaway between North and South America 3 million years ago reshaped ocean currents, strengthening the Gulf Stream and cooling the Northern Hemisphere, which in turn allowed ice sheets to grow. These ice ages sculpted the land into what we now see: the deep valleys of Yosemite, the fjords of Chile, the basins of the Great Lakes. The fossils from the last few million years are equally rich in story. In the tar pits of La Brea in California, bones of mammoths, mastodons, dire wolves, and saber-toothed cats tell of an age when giants still roamed. Tar seeped from the ground, trapping animals that wandered too close, preserving them in black pitch. In South America, caves preserve the skeletons of giant sloths taller than men, glyptodonts the size of small cars, and Macrauchenia, a strange long-necked mammal unlike anything alive today. These animals lived in climates that swung between warm and glacial, adapting as forests spread and retreated. Human beings eventually entered this stage, crossing from Asia into North America during the Ice Age, following herds across the Bering Land Bridge. They too became part of this long history, shaping the land even as it shaped them. The continents continue to move. Earthquakes ripple through California, volcanoes rise in the Andes, and coastlines shift slowly year by year. The land that was born from collisions, rifts, and drifting plates remains alive with motion. The fossils buried across the Americas are not just remnants of creatures long gone, but records of the interplay between moving continents, changing climates, and evolving life. From the ancient seas of the Burgess Shale to the redwood stumps of Florissant, from the dinosaur graveyards of Hell Creek to the fish-filled stones of Araripe, the story of the Americas is vast, unbroken, and still unfolding. Looking at the shape of the world today, with North America and South America standing proudly in the western half of the planet, separated from Europe and Africa by the wide Atlantic Ocean, It is easy to forget that the lands have not always looked this way. Long before there were cities, before there were forests as we know them, and even before there were dinosaurs, the continents were not scattered as they are now. Instead, they were gathered together in giant supercontinents that formed, broke apart, drifted, and reassembled over hundreds of millions of years. In these ancient ages, the lands that would one day become the Americas played a key role, joining, splitting, and shifting as parts of mighty land masses with names that echo with a sense of lost time: Pangaea, Gondwana, and Laurasia. In the far reaches of Earth's deep past, nearly 3 billion years ago, the first great continental fragments were already moving across the newborn oceans. But the most famous of the great assemblies of land was Pangaea, the supercontinent that formed about 330 million years ago. Its name means all Earth, and it truly was, for nearly all the land of the planet was drawn into one single continent. In that giant stretch of rock and soil and mountains, the lands that would later split into North America and South America were locked into place alongside Africa, Europe, Asia, and even the hidden land masses that later drifted to become India and Australia. America was not a distant land on the far side of the ocean, but a crucial piece in the puzzle of Pangaea, pressed tightly against other continents, forming mountain chains, sharing climates, and hosting animals and plants that could walk freely from one side of the world to the other. If one could have stood in North America during the days of Pangaea, the land would not have felt familiar at all. The Appalachian Mountains, which now roll gently across the eastern United States, were then as high and sharp as the young Himalayas. These mountains were born in the violent collision when North America slammed against Africa and Europe. The continents crashed together with such force that entire stretches of rock folded, lifted, and crumpled upward. The Appalachian chain was the scar of Pangaea's making, and its height in those days rivaled any mountain range alive today. Dinosaurs did not yet walk the earth when these mountains first rose, but the forests and swamps that grew around them teemed with giant insects, early reptiles, and lush plants that would one day turn into coal. The very energy that people burn in modern times to light their homes and fuel their factories was formed in the Pangaean world, buried under ancient soils that once lay at the feet of mountains, born from America's role in the supercontinent. Farther south, the land that would one day be South America was not yet the continent we know. It was wedged firmly against Africa, forming a continuous stretch of land. The Sahara Desert and the Amazon rainforest, which now stand in such contrast, were then parts of a single connected landmass. Rivers crossed freely, climates blended, and animals roamed without borders. Fossils found today in Brazil and in Western Africa reveal creatures that lived on both sides of what is now the Atlantic Ocean. Giant freshwater reptiles, fish, and plants left their marks in rocks that proved the two continents were once one. The split that created the Atlantic had not yet come, and South America was an anchor in the southern stretch of Pangaea, a bridge that tied together the lands of Gondwana. Gondwana itself was another mighty supercontinent, older and longer lasting than Pangaea. Forming more than 500 million years ago, it gathered together South America, Africa, India, Antarctica, and Australia. In those days, North America was not a part of Gondwana but drifted elsewhere, caught in other collisions and breakups. Yet Gondwana would not remain alone forever, for it was destined to meet with the northern continents and form the complete circle of Pangaea. South America was central in that story, carrying with it vast forests, ancient mountain ranges, and early ecosystems that would shape the face of life on Earth. Its position near the heart of Gondwana gave it connections to Africa and Antarctica, and even today scientists find traces of these connections in the rocks of the Andes and the fossils buried deep within the icy ground of the Antarctic. Plants and animals that spread across Gondwana left descendants on every continent that once shared its soil, and South America was one of the keystones of this great expanse. As millions of years passed, Pangaea began to stretch and crack. The forces inside the Earth, the constant rising and falling of heat from the mantle below, could not leave such a massive land unbroken. Great rifts opened, first as long valleys, then as widening seas. North America began to pull away from Africa, and South America began to drift from its place beside the southern continents. The Atlantic Ocean was born in fire and lava, tearing open slowly year by year over countless ages. The scars of this separation remain today in the mirrored coastlines of Brazil and West Africa, where the curves of the land seemed to fit together like pieces of a broken plate. America's role was once again central, for as it drifted apart, it reshaped the oceans and the climates of the entire planet. Yet the story of supercontinents does not rest only with Pangaea and Gondwana. There was also Laurasia, the northern giant that formed when North America, Europe and Asia came together. After Pangaea broke apart, the Earth was split into two major land masses. To the north lay Laurasia, carrying North America and Eurasia, and to the south lay Gondwana, with South America and its southern companions. Laurasia was the world of the great northern forests, of plains where dinosaurs roamed, of seas that flooded vast interiors. North America was the beating heart of Laurasia, linked across shallow seas to Europe and Asia. Animals moved from one region to another with ease, and their fossils are today found across all three continents, proof of those ancient highways of life. The horned dinosaurs of North America, the duck-billed hadrosaurs, the tyrannosaurs that ruled the land, all had relatives and ancestors that could trace their roots through Laurasia. In those times, the line between North America and Eurasia was not as clear as the Atlantic makes it today. South America, meanwhile, remained with Gondwana, a continent apart, home to its own strange and unique creatures. During the later days of the dinosaurs, South America was a land of giant sauropods, the long-necked titans that grew larger than any land animals before or since. It was also the land of the fearsome Giganotosaurus, a predator even larger than the famous Tyrannosaurus of the north. These creatures thrived in part because South America's role in Gondwana had given it vast stretches of fertile plains and forests, nourished by climates shaped by its southern connections. When Gondwana itself broke apart, South America carried with it a legacy of unique plants and animals, drifting into isolation where they evolved in ways that left a mark on the world even after the age of dinosaurs ended. The story of America in the ancient supercontinents is also written in the deep rocks beneath our feet. In the Canadian Shield, one of the oldest pieces of continental crust in the world, there are stones that were already ancient when Gondwana first rose. These rocks preserve the memory of collisions and rifts from billions of years ago, each one a chapter in the long tale of continents joining and breaking apart. The bedrock of North America carries the scars of Pangaea's rise, the folding of mountain belts, the remains of volcanic arcs that burned when oceans closed. In South America, the Andes stand as living testimony to the collisions that shaped Gondwana and its later movements, a mountain range that still grows today as tectonic plates grind against one another. Every valley and ridge, every fossil bed and mineral deposit tells a piece of the story of America's role in the supercontinents. The climates that America knew during these times were unlike anything we can easily picture. When Pangaea stretched from pole to pole, the interiors of the continent were dry and harsh, deserts larger than any today because the rain could not reach so far inland. North America and South America alike shared in these extremes, their ecosystems shaped by the giant landmass they were part of. Later, when Laurasia and Gondwana split, new coastlines brought moisture and lush forests spread across vast areas. Swamps, deltas, and shallow seas covered much of North America, leaving behind the thick layers of limestone and shale we find today. South America, closer to the equator in those times, was warm and wet, a land of tropical forests where strange creatures thrived. The very placement of America within these supercontinents determined not only its geography, but the destiny of its life. Fossils are the whispers of these lost worlds, and in America they tell the story with vivid detail. In North America, fossils of early reptiles and amphibians lie in rocks that date back to the Carboniferous and Permian periods, times when the land was locked into Pangaea. The famous petrified forests of Arizona, the coal beds of Pennsylvania, and the ancient swamps of Illinois are all pieces of this story. In South America, the rocks of the Paraná Basin preserve the creatures of Gondwana, from giant amphibians to early dinosaurs that walked across the land long before it became isolated. Fossils of similar species on both South America and Africa prove their shared history, fossils that only make sense when seen in the light of supercontinents. Even the plants tell the tale, with fossilized leaves of the same species found in Brazil and in India, showing the path of life across Gondwana. As the millions of years rolled on, the drift of the Americas would continue to shape the planet. But in those deep ages, in the times of Pangaea, Gondwana and Laurasia, America was never just a far-off land. It was a cornerstone in the building and breaking of the greatest landmasses the Earth has ever known. The story of the great mountain builders is written not in books but in the stones of the Earth itself, in the ridges and valleys that stretch for hundreds and even thousands of miles, and in the layers of rock that whisper of deep time. When we speak of the Rockies, the Andes, the Appalachians, and the Sierra Ranges, we are not just naming familiar landscapes, but we're calling upon the ancient forces that shaped them, forces that worked in silence over tens of millions of years. Mountains are not built in a single age, nor are they the product of a single event. They rise, they fold, they crumble, and they are reborn again. They are the fingerprints of colliding continents, of oceans that opened and closed, and of restless magma pushing upward from the Earth's interior. The Appalachians, among the oldest of these ranges, began their story long before the others. More than 480 million years ago, during the Ordovician period, the eastern margin of what would one day become North America was a restless frontier. Tiny volcanic island arcs drifted across the Proto-Atlantic Ocean, colliding with the edge of Laurentia, the ancient core of the continent. Each collision crumpled the crust, raising peaks that rivaled today's Himalayas. Over hundreds of millions of years, more collisions followed. Africa and Europe pressed against North America when the supercontinent Pangaea formed about 300 million years ago. The Appalachians then stood as a towering range stretching across a young world. Time, wind, and rain have worn them down so that today they are gentle ridges and rolling green highlands, but the rocks still remember the fury that once thrust them skyward. In valleys like the Shenandoah and in the folded ridges of Pennsylvania, one can still trace the scars of those ancient continental embraces. The story of the Rockies is much younger, though no less dramatic. Around 70 to 80 million years ago, during the late Cretaceous and into the early Paleogene, the western edge of North America was caught in a dance of plates. The Farallon Plate slid beneath the continent at a shallow angle, pressing hundreds of miles inland. This unusual angle forced the crust to warp and uplift far from the coast, raising a chain of mountains that stretched from Canada to New Mexico. Unlike the Appalachians, which were carved during the assembly of Pangaea, the Rockies rose during its breaking. They became the spine of the continent, their jagged peaks and snow-capped summits dividing rivers, climates, and even cultures. The Rockies hold the memory of inland seas that once covered the plains to their east, of dinosaurs that roamed along their shores, and of glaciers that later carved valleys like Colorado's Estes Park. Even now, their peaks rise more than 14,000 feet into the sky, reminders of the restless forces that continue to shape the land. Far to the south, the Andes stretched like a great serpent along the western edge of South America, the longest continental mountain range on Earth. Their birth began tens of millions of years ago and continues to this day, for they are mountains still in the making. Here the Nazca Plate dives beneath the South American plate, a dramatic subduction that feeds volcanoes and pushes up peaks that scrape the heavens. The Andes are home to Aconcagua, nearly 23,000 feet high, and to chains of volcanoes that belch smoke and fire. Yet they are also lands of high plateaus, of the Altiplano where vast salt flats shimmer under the sun, and of ancient civilizations that built cities in the clouds. The Incas left stone terraces clinging to the Andean slopes, while llamas and alpacas still graze in valleys where thin air and freezing nights mark the harshness of mountain life. Glaciers crown the higher summits, rivers carve deep gorges like the Colca Canyon, and earthquakes remind the people who live there that these mountains are still rising, still restless, still alive. The Sierra Nevada range tells another story, one bound tightly with the fires of Earth's deep interior. About 100 million years ago, as the Farallon Plate continued its slow descent beneath North America, great bodies of molten rock cooled within the crust. They hardened into massive granite formations, though at the time they were buried far beneath the surface. Over tens of millions of years, erosion stripped away the softer layers above, revealing the gleaming white granite that now forms the heart of the Sierra. Peaks like Mount Whitney soar more than 14,000 feet, while Yosemite Valley shows walls of stone carved by glaciers that once blanketed the range. The Sierra stand as a record of both fire and ice, built by magma deep within the earth and sculpted by frozen rivers that came much later. Their beauty inspired poets, explorers, and conservationists. John Muir walked their trails and sang their praises, and they became the cradle of the national park idea. Yet long before humans arrived, the Sierra had already endured countless ages of uplift, erosion, and rebirth. When we set the Appalachians beside the Rockies, the Andes, and the Sierra, we see the different ages of mountains, almost like stages of life. The Appalachians are the elders, worn and softened, their sharpness long since dulled. The Rockies and the Sierra are middle-aged, still tall and jagged, their glaciers and rivers actively carving them. The Andes are youthful, still growing, their volcanoes alive and their peaks thrusting ever higher. Each range carries the memory of a different chapter in Earth's tectonic saga, a different way in which the planet reshaped itself. The building of mountains is always tied to the movement of tectonic plates. When continents collide, as in the case of the Appalachians, the crust folds and thickens. When an oceanic plate dives beneath a continental one, as in the Andes, volcanoes rise and mountains are pushed upward. When the angle of subduction is shallow, as in the case of the Rockies, the forces reach far inland, lifting ranges far from the coast. When molten rock cools within the crust, as with the Sierra, mountains can later emerge as erosion strips away the overlying layers. These processes take place over millions of years, so slowly that no single generation can see the full result, and yet the evidence is written in stone, in tilted strata, in granite domes, in fossil seashells found high above sea level, and in valleys carved by rivers and glaciers. The Rockies, stretching from Canada through Montana, Wyoming, Colorado, and into New Mexico, are not uniform. Some parts are massive granite cores, others are folded sedimentary rocks lifted high into the air. The Canadian Rockies show sharp limestone peaks, while Colorado hosts the Great 14ers that challenge climbers each summer. To the west of the Rockies lies the Basin and Range Province, where the crust stretched and cracked, forming valleys and smaller ranges, while to the east spread the vast Great Plains, once covered by shallow seas. This contrast between high peaks and flat plains tells the story of forces that lifted mountains on one side while leaving seas on the other. The Andes, stretching nearly 5,000 miles from Venezuela to Chile, are equally diverse. In the north they are humid and forested, in the central region they give way to the dry Atacama Desert, and in the south they become windswept and icy. Within them lie some of the world's highest volcanoes, such as Ojos del Salado, and some of the deepest gorges, like the Cotahuasi Canyon. These mountains not only shape climate, forcing moist winds to drop rain on one side while leaving deserts on the other, but they also shape human history. Civilizations rose on their slopes, adapted to thin air, and built roads that ran for thousands of miles. The Andes continue to influence the lives of millions today, offering fertile valleys, mineral riches, and challenges of earthquakes and landslides. The Appalachians, though lower in height, are rich in history and resources. Coal seams lie within their folded layers, once fueling industries and shaping towns. Rivers like the Tennessee and the Susquehanna cut through their ridges, creating passageways that guided migration and trade. Their forests provided timber and shelter, their valleys became farmland, and their beauty drew settlers who found both hardship and inspiration in their hills. Long before Europeans arrived, native peoples lived in these valleys, hunted in the forests, and told stories of the spirits of the mountains. The Appalachians, softened by time, remain a place of human connection, shaped as much by culture as by geology. The Sierra Nevada tell of dramatic contrasts. To the west they drop gently into the great Central Valley of California, one of the most fertile agricultural regions in the world. To the east they fall sharply toward the desert basins of Nevada, leaving rain shadows where little grows. Their snowpacks feed rivers that sustain millions, their granite cliffs challenge climbers, and their alpine lakes glimmer under clear skies. Glacial polish can still be seen on their domes, while moraines mark the paths of vanished ice. Beneath their peaks, gold was discovered in the mid-19th century, sparking the rush that brought waves of settlers westward. Thus, the Sierra not only shaped the land but also the course of human events. All these mountain ranges remind us that the Earth is never still. What seems eternal to us, towering peaks, vast valleys, endless ridges, is in truth fleeting on geological timescales. The Appalachians were once Himalaya high and now are worn down. The Rockies, tall and dramatic, will one day erode into gentler forms. The Andes continue to climb skyward, but erosion battles their growth even as they rise. The Sierra reveal their granite hearts because erosion stripped away their softer coverings. Each range is both growing and dying, both rising and falling, depending on the scale of time one chooses to see. These mountain builders are also climate makers. They redirect winds, capture rain, and create deserts. The Rockies block moist Pacific air, feeding forests on their western slopes while leaving the Great Plains drier. The Andes create the Atacama Desert, one of the driest places on Earth, by preventing moisture from reaching its interior. The Appalachians influence weather across the eastern United States, while the Sierra store snow that sustains California's rivers in summer. Mountains create microclimates, shelter unique plants and animals, and guide the flow of rivers that carve the land further still. The Appalachians whisper of ancient seas, the Rockies roar with youth, the Andes tremble with fire, and the Sierra gleam with granite faces. Volcanoes and fire have always been among the greatest forces shaping the surface of the Earth, and nowhere is this more powerfully seen than around the immense curve of the Pacific Ocean, in the vast region known as the Ring of Fire. This gigantic ring, stretching for many thousands of miles around the ocean, is filled with fiery mountains, restless earth, smoking vents, and great underwater ridges. It is here that continents collide, ocean floors dive beneath other plates, and molten rock rises with tremendous force. The Ring of Fire is not a gentle place, but one of the most dramatic theatres where land itself is born, destroyed, and born again. Along its arcs lie more than 3/4 of all the active volcanoes on our planet, each one like a breathing wound in the crust of the Earth. The Ring of Fire runs along the western edge of the Americas, curves upward through Alaska, crosses over into the Kamchatka Peninsula of Russia, bends down through Japan, the Philippines, and Indonesia, then stretches southward through New Zealand. Entire nations sit upon its restless boundaries. For countless centuries, people have lived, farmed, built cities, and created myths in the shadow of these fiery mountains, both fearing and revering them. When a volcano erupts along this circle, it is as though the Earth itself is opening its heart to reveal its deepest fires. Molten rock, called magma when underground and lava when it spills onto the surface, forces its way through cracks and vents. Ash clouds rise like towers into the sky, darkening daylight and spreading across lands far beyond the eruption site. Great rivers of lava roll down slopes, sometimes glowing red, sometimes blackening as they cool, burying forests, fields, and villages beneath their heavy weight. The ground trembles with earthquakes that often precede or follow eruptions, for the two forces are bound together. In South America, the Great Andes mountain chain is lined with some of the most dangerous volcanoes of the Ring of Fire. Towers like Cotopaxi in Ecuador, one of the highest active volcanoes on Earth, and Mount Villarrica in Chile, whose glowing summit has been called the Devil's House, rise proudly above landscapes shaped by fire. The Incas and other ancient peoples who lived in these lands saw these mountains as gods, as sacred beings that demanded respect. They offered sacrifices to them, believing that eruptions were signs of divine anger. Even today, many communities living on the slopes of the Andes feel a spiritual connection to the fiery peaks that dominate their skies. Farther north, in Central America, fiery giants such as Fuego in Guatemala or Masaya in Nicaragua show their power with frequent eruptions. Fuego, whose name itself means fire, is known for constant activity, with explosions, ash plumes, and glowing lava fountains that have been seen by generations of people. The Spanish conquistadors who arrived centuries ago were astonished by the sight of Masaya, which they called the mouth of hell. They lowered crosses into the crater, hoping to exorcise what they thought was a gateway to the underworld. Yet for the local peoples, Masaya was a place of offering, where precious objects were thrown into the flames as gifts to the gods of fire. In North America, the Ring of Fire is marked by the Cascade Range, running through Washington, Oregon, and Northern California. Here lie volcanoes like Mount St. Helens, Mount Rainier, Mount Hood, and Mount Shasta. In the year 1980, Mount St. Helens unleashed one of the most destructive eruptions in American history. The entire top of the mountain was blown away in an explosion that flattened forests, darkened skies with ash, and sent avalanches of rock and mud roaring down valleys. The blast was heard hundreds of miles away, and its force was compared to the detonation of many nuclear bombs. This eruption showed the people of the modern world that volcanoes remain as dangerous today as they were in ancient times, no matter how much technology or science we possess. travel farther north into Alaska, and the land bristles with volcanic peaks. Here, the Pacific Plate dives beneath the North American Plate, creating a chain of islands known as the Aleutians, each one with its smoking mountains. Many of these volcanoes are remote, their eruptions witnessed only by seabirds, seals, and occasional passing ships, yet they play a huge role in shaping the landscape. Clouds of ash from Alaskan eruptions have drifted as far as Asia and North America, interrupting air travel and reminding us how even distant volcanoes can affect lives thousands of miles away. Crossing the ocean to Asia, the Ring of Fire continues with even more fury. In Japan, one of the most famous volcanoes in the world, Mount Fuji, rises like a perfect white cone above the land. Though it has not erupted since the early 18th century, it remains active, and millions of people live within reach of its power. Japanese culture is filled with paintings, poems, and legends honoring Fuji, seeing it both as a symbol of beauty and a reminder of fiery destruction. Japan has many other volcanoes too, such as Mount Unzen, which erupted in the year 1991, sending pyroclastic flows that destroyed entire villages and killed scientists and photographers who had come to study its behavior. South of Japan, the Ring of Fire sweeps through the Philippines, a nation built from volcanoes rising out of the sea. One of the most destructive eruptions of the 20th century happened here in the year 1991, when Mount Pinatubo awoke after centuries of quiet. It hurled so much ash and gas into the sky that it cooled the Earth's climate for several years, dimming sunlight across the globe. Entire towns were buried under ash, rivers turned to mudflows, and thousands were forced to flee their homes. Yet even such devastation carried strange gifts, for the eruption left behind fertile soils that future generations would cultivate. Further along the arc, Indonesia stands at the very heart of the Ring of Fire. It is a nation of more than 17,000 islands, most of them shaped by volcanoes. Among its fiery mountains is Krakatoa, which in the year 1883 erupted with a force so great that the sound of the explosion was heard nearly 3,000 miles away. The eruption destroyed much of the island itself, sent tsunamis crashing into coasts, and darkened skies across the Earth. People in Europe and America reported strange sunsets, glowing red and purple, caused by volcanic ash floating high in the atmosphere. More than 30,000 people lost their lives in that disaster, yet the sea eventually gave birth to a new island in the same place, a volcano called Anak Krakatau, or the Child of Krakatoa, which continues to grow today. Indonesia is also home to Tambora, whose eruption in the year 1815 was the most powerful in recorded history. The explosion blew away the top of the mountain, leaving behind a crater more than 4 miles wide. Ash and dust filled the sky, blocking sunlight and causing what became known as the Year Without a Summer. Across Europe and North America, crops failed, livestock died, and people starved as frost struck in June and July. The cold and hunger even inspired new works of art and literature, as people felt the gloom of a world darkened by fire from the ring. To the south lies New Zealand, whose fiery heart is seen in the Taupo volcanic zone. Here, Lake Taupo itself was created by one of the greatest eruptions of the past 20,000 years. When it erupted nearly 2,000 years ago, it sent plumes so high into the sky that people in China recorded the strange glow. The land around Taupo still steams with hot springs, geysers, and mud pools, showing that the fire beneath is never far away. Beneath the waters of the Pacific, countless underwater volcanoes rise unseen, building chains of islands and seamounts. Hawaii, though not on the edge of the Ring of Fire but rather above a hotspot in the middle of the Pacific Plate, adds to the fiery story. Its islands were created entirely by volcanoes, rising from the sea over millions of years. Mauna Loa, the largest volcano on Earth, and Kilauea, one of the most active, are constant reminders of the living planet beneath our feet. The people of Hawaii tell ancient stories of Pele, the goddess of fire, whose restless spirit shapes the land with lava flows. For them, the volcano is not merely destruction but creation, turning ocean into new land. The Ring of Fire is not just about eruptions, it is about the endless cycle of creation and destruction. When lava flows, it destroys everything in its path, yet as it cools and breaks down, it creates rich soils that feed forests, crops, and entire civilizations. The vineyards of Chile, the rice terraces of Java, and the tea fields of Japan all owe their fertility to volcanic soils. The ashes that once killed and buried can, over generations, nourish and sustain. The same forces that topple cities also build mountains and islands where none existed before. Throughout history, people have tried to live with the fiery moods of the Ring of Fire. Some have seen volcanoes as gods, some as demons, and others as simple natural forces to be studied and understood. Scientists today place instruments on volcanoes, measuring gas emissions, watching ground deformation, and listening for the rumbling signs of movement deep within. They try to forecast eruptions, to give warnings so that lives may be saved. Yet even with modern knowledge, the might of the earth cannot always be predicted or controlled. Volcanoes can sleep for centuries, silent and harmless, then suddenly awaken with fury. The stories of the Ring of Fire are written in lava flows, in ash layers buried deep in soil, in the broken rocks of mountainsides. They are also written in human memory, in tales of escape and survival, in myths of gods and monsters, in art that depicts glowing mountains against night skies. From the earliest people who watched fire fountains with awe, to the scientists of today who fly into ash clouds to measure their chemistry, the Ring of Fire has been a constant presence in the history of humankind. Its shaping power goes beyond single eruptions. Over millions of years, the movement of the tectonic plates along this ring has lifted mountain chains, opened rift valleys, and built island arcs. Earthquakes, which often come hand in hand with volcanoes, have toppled cities from Chile to Japan, from Alaska to the Philippines. Entire coastlines have risen or sunk during great tectonic events, reminding us that the land we stand on is never fixed. The Pacific Ocean itself, surrounded by this Ring of Fire, is a stage where the restless heart of the earth is most visible. Even today, millions of people live within sight of active volcanoes in the Ring of Fire. Glaciers have long been powerful, silent sculptors of the land, their immense weight and slow, relentless movement shaping the Americas in ways that are still visible today. Thousands upon thousands of years ago, during the most recent ice age, immense sheets of ice, sometimes more than a mile thick, slowly crept across the northern continents, stretching from what is now Canada and Alaska far down into the northern United States. These icy rivers, known as glaciers, were not still, lifeless masses. They were alive in their own slow, grinding way, pushing rocks, soil, and debris along their paths as they advanced and retreated over centuries and millennia. The movements of these glaciers were like a vast frozen tide, and as they moved, they gouged deep valleys, polished jagged rock surfaces, and left behind enormous deposits of soil and rock that would shape the very geography of the Americas for countless generations. In regions such as the northeastern United States and eastern Canada, the glaciers carved out sweeping valleys that now cradle rivers and lakes. The Hudson River Valley, for instance, owes its deep, dramatic U-shaped profile to these ancient ice rivers. Unlike the V-shaped valleys formed by flowing rivers, glacial valleys have broad, flat floors and steep, towering sides, as if the ice itself had scooped away the softer rock, leaving behind an unmistakable mark of its passage. In the Great Lakes region, glaciers transform the landscape on an even grander scale. Lake Superior, Lake Michigan, Lake Huron, Lake Erie, and Lake Ontario, together forming the world's largest group of freshwater lakes, were all sculpted by the colossal advance and retreat of ice. During periods when the glaciers reached their southernmost limits, they gouged out depressions that would later fill with meltwater as the ice melted, giving rise to these enormous bodies of water. The weight and movement of ice also depressed the land itself, which in some areas has only slowly rebounded over the thousands of years since the ice receded. As glaciers moved, they carried with them enormous amounts of rock and soil, often grinding them into fine dust that was deposited far from its original source. This glacial till, as geologists call it, formed rolling hills, plains, and moraines, ridges of debris left behind at the edges of glaciers. In the Midwest, for instance, the fertile soils that today support vast fields of corn, wheat, and soybeans are largely the result of glacial deposits. As the ice sheets slowly melted, they left behind sediment-rich plains, perfectly suited for agriculture. The glaciers also left behind erratics, enormous boulders that seem to have been dropped from the sky, transported sometimes hundreds of miles from the bedrock from which they originated. In New England, such boulders rest in fields and forests, silent witnesses to the immense forces that moved them. Glacial lakes were another significant legacy of the Ice Age. As glaciers carved out depressions in the land, meltwater pooled in these newly formed basins, creating lakes of various sizes. Some of these lakes, such as the Finger Lakes in New York State, are long and narrow, a direct reflection of the path of glacial movement. Others, like the vast Lake Winnipeg in Canada, were formed by the ice-blocking natural drainage and creating enormous water bodies that could persist long after the ice had gone. The constant melting and refreezing of ice, combined with the weight of glaciers pressing down on the Earth, caused subtle changes in the elevation of the land, which in turn affected drainage patterns, river courses, and the creation of wetlands and marshes across formerly glaciated regions. The glaciers also sculpted some of the most iconic mountain landscapes in North America. In the Rocky Mountains, the Sierra Nevada, and the Cascades, glacial activity during the Ice Ages deepened valleys, sharpened peaks, and smoothed ridges, leaving behind dramatic scenery that continues to draw the awe of visitors today. Alpine glaciers, which form in high mountain regions, carved cirques, bowl-shaped depressions that often house small lakes called tarns, and left behind jagged ridges known as arates. These features, though smaller than the continental scale effects of ice sheets, added layers of complexity to mountain topography, creating ecosystems that were distinct from those found in lower, non-glaciated areas. Glacial activity was not uniform. It fluctuated with changing climates. During periods known as glacial maxima, ice sheets expanded to their furthest reach, covering vast portions of North America. During interglacial periods, when the climate warmed, glaciers retreated, leaving behind a transformed landscape. These cycles of advance and retreat were not smooth or predictable. Sometimes glaciers paused for centuries, their edges stabilized, forming complex terminal moraines, ridges built up from rock and soil pushed forward by the ice. In other places, sudden surges of ice caused dramatic advances that could bury forests and reshape river valleys. The constant movement of ice created complex patterns of erosion and deposition, resulting in landscapes that are a mosaic of valleys, ridges, plains, and lakes, each telling the story of ancient ice. South of the great continental ice sheets, smaller mountain glaciers played a similar role, particularly in the Andes of South America. Stretching along the western edge of the continent, these glaciers carved deep valleys that now cradle towns and cities, and they left behind terraces of rock and sediment that reflect thousands of years of ice movement. In Patagonia, the southernmost region of South America, the glaciers sculpted fjords and lakes that stretch for hundreds of miles, a testament to the relentless power of ice in shaping the land. Meltwater from these glaciers fed rivers that cut new channels through the landscape, creating wetlands, marshes, and fertile plains along their course. Glacial activity also influenced the distribution of plants and animals. As glaciers advanced, they pushed species southward into refuges where conditions were more favorable, and as the ice retreated, these species slowly recolonized newly exposed lands. The patterns of plant succession, from mosses and lichens that first colonized bare rock, to shrubs and forests that followed, were directly linked to the timing and extent of glacial retreat. Animal populations followed these changes, moving with shifting habitats, sometimes becoming isolated in pockets of suitable environment, leading over time to unique adaptations and in some cases new species. The formation of glacial lakes and rivers provided new aquatic habitats, while glacially carved plains and valleys offered space for large herbivores to graze and predators to hunt. Glacial sediments also influenced human history long after the ice had disappeared. Native peoples who arrived in North America thousands of years ago found a landscape already profoundly altered by ice. The fertile soils of the Midwest, the abundant freshwater lakes of the Great Lakes region, and the rich river valleys of the Northeast were all legacies of glacial activity, providing resources that would support hunting, fishing, and later agriculture. Early settlers and explorers also relied on glacially carved valleys for transportation routes, navigating rivers that flowed along glacial troughs, or following passes through mountainous terrain smoothed by ice. In addition to shaping the surface of the land, glaciers left their mark on the very soil itself. Glacial erosion exposed bedrock in many regions, creating areas rich in minerals that would later be mined for human use. In parts of Canada and the northern United States, the grinding action of glaciers revealed deposits of iron, copper, and other metals, which eventually became the foundation of mining industries. The soils deposited by glaciers, a mix of sand, clay, gravel, and silt, created patterns of drainage that influenced agriculture, settlement, and the formation of towns and cities. Even the shapes of coastlines were influenced by the ice. As glaciers advanced, they pressed down on the land, lowering its elevation, and as they melted, sea levels rose due to the influx of meltwater. In some regions, the land rebounded slowly after the ice retreated, creating features such as raised beaches, terraces, and new river deltas. In places like the Gulf of St. Lawrence and parts of the Atlantic coast, these changes resulted in complex patterns of inlets, bays, and islands, where land and water interweave in shapes directly sculpted by glacial action. The pace of glacial movement varied dramatically depending on local conditions. In some areas, ice crept along at just a few inches per year, barely perceptible, while in other regions, glaciers surged forward at speeds of tens of feet per day, driven by the pressure of accumulated snow and the lubricating effect of meltwater at their bases. These surges could dramatically reshape valleys in a matter of years, carving new channels, damming rivers, and creating temporary lakes that would later drain in catastrophic floods. The rhythm of advance and retreat left a landscape that is a record of time, with layers of till, outwash, and glacial lake sediments stacked upon one another, each layer preserving evidence of past ice ages. Glaciers also transported enormous amounts of rock, grinding and polishing surfaces as they moved, creating smooth, striated bedrock in some places and chaotic piles of rubble in others. Glacial polish, grooves, and striations are often still visible today on exposed rock surfaces, providing geologists with clues about the direction of ice flow and the intensity of glacial movement. The rocks themselves often show signs of immense pressure, with fractures and scarring that tell a story of relentless grinding ice. Erratic boulders, sometimes the size of houses, were carried over hundreds of miles, dropped seemingly at random across plains and hills, each one a fragment of distant mountains transported by ancient glaciers. As the glaciers melted, they formed massive rivers of meltwater, carving new valleys and depositing sediments far from their sources. These meltwater channels were temporary in the life of the glacier, but left permanent marks on the landscape. Some of these channels became rivers and streams that still flow today, while others formed deep gorges and ravines that cut through bedrock. The deposition of sediments from these meltwater rivers created extensive outwash plains, gently sloping areas of sand and gravel that stretch for miles, often forming natural levees, terraces, and fertile fields. In some areas, the interplay of ice and rock created dramatic scenery, such as the fjords of Alaska and British Columbia, where deep glacially carved valleys were flooded by rising seas. In the Canadian Shield, vast expanses of exposed Precambrian rock were scoured clean by glaciers, leaving behind a patchwork of lakes and rugged terrain. In contrast, the central plains of the United States received thick layers of glacial till, creating gently rolling landscapes dotted with ponds, lakes, and wetlands. These contrasting landscapes illustrate the diverse effects of glacial activity depending on local topography, rock type, and the behavior of the ice itself. The legacy of glaciers extends into human memory and culture. Many place names in North America reflect glacial origins, from the numerous glacier lakes in the Rockies to the Icefields Parkway in Alberta. Folktales and oral histories of indigenous peoples often reference landscapes shaped by great floods and shifting ice, preserving a memory of the immense forces that created the land they lived on. Even the presence of certain plant species, animals, and freshwater resources can be traced back to glacial shaping, showing how deeply ice ages influenced the patterns of life across the continent. Glacial geology also left behind features known as drumlins, smooth, elongated hills formed beneath moving ice, which indicate the direction of glacial flow. Eskers, long ridges of sand and gravel deposited by streams flowing beneath glaciers, also mark the paths of former ice sheets. Kettles, depressions left by melting ice blocks, often filled with water to form small lakes, provide another example of the intricate ways in which glaciers sculpted the landscape. Together, these features create a complex interwoven tapestry of hills, valleys, lakes, and plains, each bearing silent testimony to the ice that once dominated the land. Even in areas that were not completely covered by ice, glacial effects were felt. Periglacial regions, just beyond the edge of the ice sheets, experienced repeated freezing and thawing of soil, creating patterned ground, frost heaves, and other unique landforms. In these areas, meltwater streams carved channels and deposited sediments, creating fertile soils and diverse landscapes. The edges of glaciers were zones of intense geological activity, where ice, water, and sediment interacted constantly, shaping landforms in ways that are still visible thousands of years later. The influence of glaciers extended to rivers and their courses. Many of today's major rivers, including the Mississippi, St. Lawrence, and Columbia, follow paths influenced by glacial sculpting, often flowing along valleys carved by ice or through regions where glacial deposits directed their flow. The sediment carried by glaciers and meltwater enriched floodplains, creating fertile areas that would later support diverse ecosystems and human agriculture. Waterfalls, rapids, and river terraces often mark the sites where glacial ice altered the natural slope of the land, leaving behind abrupt changes in elevation and flow. Glacial lakes and rivers were also habitats for countless species of fish, birds, and mammals. As ice retreated, these water bodies provided corridors for migration and colonization, while wetlands and marshes supported amphibians, insects, and plants that thrived in these newly formed ecosystems. Glacial outwash plains, with their mix of sand, gravel, and finer sediments, created habitats for pioneer species that could survive in unstable, nutrient-poor soils, eventually paving the way for more complex plant and animal communities. The story of glaciers is a story of slow, inexorable change, of immense forces shaping land and life across millennia. Valleys carved into bedrock, lakes formed from ice-scoured basins, plains enriched with glacial till, and rivers redirected by melting ice. All these features reflect the tireless work of glaciers. The rhythms of ice advance and retreat influence not only the physical landscape, but also the distribution of plants, animals, and eventually human societies, leaving a legacy that is still read in the land, still felt in the soils, and still visible in the patterns of lakes, rivers, and valleys across the Americas. Glacial movement also left subtle marks that persist even today. The alignment of boulders, scratches on rock faces, and the very orientation of valleys often preserve a record of ice flow from tens of thousands of years ago. Scientists can read these markers to reconstruct the history of ice sheets, revealing how glaciers spread across continents, paused for centuries, and finally melted, leaving behind a transformed world. In some areas, the presence of layered sediments tells a story of repeated advances and retreats, of climate swings, and of ice that reshaped the face of the Earth again and again. Even now, remnants of glaciers linger in high mountain regions. The Rockies, Sierra Nevada, Cascades, and Andes still harbour glaciers, though much smaller than their Ice Age predecessors. These glaciers continue to erode rock, deposit sediments, and influence local hydrology, echoing the processes that shaped vast regions of North and South America thousands of years ago. Meltwater from these modern glaciers feeds rivers that sustain ecosystems, while glacially polished peaks and valleys remain landmarks of past ice activity. In the vast expanses of Canada, Alaska, and Patagonia, the imprint of continental ice sheets is most dramatic. There, the landscape tells of ice that once stretched over millions of square miles, grinding down mountains, creating deep lakes, and spreading sediment across plains. Moraines, drumlins, eskers, and erratics mark the edges of this ice, while deep valleys and fjords reveal the paths of its advance. In more temperate regions where ice sheets were thinner or intermittent, rolling plains, scattered lakes, and fertile soils reflect the deposits left behind, while subtle striations on bedrock hint at the passage of ice over harder surfaces. Glacial history is also recorded in underground sediments. Layers of sand, gravel, silt, and clay reveal the story of meltwater rivers and lakes, of ice pressing down on the land, and of sediments transported far from their source. Fossils found within these deposits sometimes provide a glimpse of the plants and animals that lived at the edges of ice sheets or in newly exposed lands, showing how life adapted to changing conditions, colonizing landscapes freshly revealed by retreating ice. The Americas are in many ways a canvas painted by ice. Valleys, lakes, plains, and hills are the brushstrokes left by glaciers over tens of thousands of years. The scale of their influence ranges from the massive Great Lakes to the smallest drumlin, from sweeping valleys to polished rock faces, from fertile farmland to isolated mountain tarns. Every river, every lake, and every hill shaped by ice tells a story of ancient climates, relentless movement, and the profound ability of glaciers to mold the Earth itself. Even in the present day, scientists study the patterns left behind by ice ages to understand climate change, water resources, and the evolution of ecosystems, Glacial deposits, striated rock, and erratic boulders are not just features of scenery. They are records of the past, evidence of forces that operated on a scale far beyond human perception. By tracing the paths of ancient ice, understanding the processes of glacial erosion and deposition, and examining the ecosystems shaped by these movements, one can see how profoundly glaciers influenced the Americas, shaping the land into a diverse and intricate mosaic that continues to host life in countless forms. Glacial history also left enduring features such as kettle lakes, formed when blocks of ice left behind in glacial till melted, leaving depressions filled with water. These lakes, often small but numerous, dot the landscapes of formerly glaciated regions, providing habitat for amphibians, birds, and aquatic plants. They often appear in clusters, creating complex wetland ecosystems, and their irregular shapes reflect the chaotic manner in which ice melted and retreated. The earliest migrations into the continent are thought to have occurred during the last ice age, a time when much of the northern hemisphere was covered by thick sheets of ice, glaciers stretching like frozen rivers across the land. The landscape was harsh and unwelcoming, yet it offered pathways for movement. Some scientists believe that the first people came from northeastern Asia, crossing a land bridge that connected what is now Siberia to Alaska. This land bridge, exposed by lower sea levels caused by vast amounts of water being trapped in ice sheets, stretched for hundreds of miles, forming a route known today as Beringia. It was not a frozen wasteland as one might imagine. It contained grasslands, rivers, and scattered forests, supporting herds of animals such as mammoths, bison, horses, and giant ground sloths, all of which would have been crucial sources of food for the people who travelled across it. The journey over Beringia could not have been quick. It likely took many years, with groups pausing to hunt, gather, and survive in a land that was both challenging and bountiful. Evidence of human presence in the Americas begins to appear around 15,000 to 20,000 years ago, though some discoveries suggest even earlier dates, hinting at the possibility that humans may have reached the continent as far back as 25,000 years ago. Archaeological sites such as Monteverde in southern Chile provide a remarkable glimpse into these early lives. At Monteverde, remains of huts, tools, and even preserved food have been found, showing that people were able to establish settlements far south, long before the land bridge itself may have fully disappeared under rising seas. This indicates a remarkable capacity for mobility, as humans would have had to travel thousands of miles from northern entry points through forests, mountains, rivers, and plains, adapting to changing climates and ecosystems along the way. The tools and artifacts left behind by these early peoples tell a story of ingenuity and survival. Stone tools were meticulously crafted, shaped to suit hunting, cutting, and processing food. Clovis points, which are finely worked spear tips, are among the most famous artifacts from early North America, often associated with hunting large Ice Age animals such as mammoths and mastodons. These points, sometimes measuring more than 8 inches in length, were carefully flaked from flint or chert, requiring great skill and knowledge of materials. But not all tools were designed for hunting. Scrapers, awls, and blades were used to process hides, make clothing, and build shelters, showing a sophisticated understanding of the environment and the resources available. The ability to adapt tools to specific purposes and to pass this knowledge through generations was essential for survival, allowing humans to live in regions with extreme cold, unpredictable weather, and dangerous wildlife. The migration of humans was closely tied to the availability of food. Following herds of large animals provided not only sustenance, but also an understanding of seasonal patterns. For example, mammoths and bison often moved across the plains in predictable ways, allowing hunters to plan their movements. Fishing and gathering supplemented hunting, as rivers and lakes offered fish, shellfish, and aquatic plants, while forests provided nuts, berries, and roots. Knowledge of edible plants, tracking animal behavior, and understanding weather patterns became crucial skills passed down through storytelling, shared experience, and careful observation. Every group that moved across the land carried with them the knowledge of where to find water, how to build temporary shelters, and how to protect themselves from predators, from bears to saber-toothed cats. As humans spread southward, they encountered a breathtaking diversity of landscapes and climates, each presenting its own challenges and opportunities. In the far north, tundra and icy plains dominated the landscape, with short summers and long, harsh winters. People here relied heavily on hunting large animals, creating warm clothing from hides, and developing shelters that could withstand snow and wind. Further south, dense forests and fertile river valleys offered a different kind of abundance, where gathering, fishing, and small game hunting could sustain communities. The wide plains of what is now the central United States were home to herds of bison, deer, and antelope, while the river systems of the Mississippi and Amazon allowed for fishing and seasonal agriculture in later periods. Each environment required a unique set of skills, demonstrating the flexibility and intelligence of early humans as they moved across the continent over thousands of years. The archaeological record also suggests that these first peoples were capable of remarkable feats of organization and social structure. Temporary campsites, often marked by clusters of hearths and tool-making debris, show that people worked together to hunt, prepare food, and care for children and elders. Some sites reveal evidence of long-distance trade, as materials like obsidian, shells, and pigments travelled hundreds of miles from their original sources. This implies networks of communication and exchange, where ideas, tools, and cultural practices spread alongside people themselves. Symbolic objects such as carvings, beads, and pigments indicate that humans were not only concerned with survival, but also with identity, expression, and perhaps spiritual life, leaving traces of culture that reach far beyond the utilitarian needs of everyday existence. Migration was not a single wave, but occurred in multiple phases, with groups splitting, rejoining, and moving in different directions. Some travelled along the coasts using waterways and shorelines to hunt, fish, and gather resources. These coastal migrations allowed people to move relatively quickly and access abundant marine life, from seals and fish to shellfish and seabirds. Other groups moved inland, across plains, mountains, and deserts, following rivers and game. The routes were not linear, and movements could be influenced by climate shifts, volcanic activity, or the arrival of new species, including humans themselves competing for the same resources. Each group adapted in its own way, using local knowledge to survive in specific landscapes, demonstrating a remarkable diversity of strategies and resilience. The spread of humans into the Americas also coincided with profound environmental changes. The last ice age, known as the Pleistocene, was a time of enormous glaciers covering much of northern North America, shifting coastlines, and fluctuating climates. As glaciers advanced, they pushed animals and humans southward. As they retreated, new lands opened for exploration and settlement. Rising sea levels gradually submerged the Bering Land Bridge, isolating populations in North and South America and leading to the development of distinct cultures and technologies. Forests expanded into areas once covered by ice, rivers carved new valleys, and megafauna roamed the continent until changes in climate and hunting pressures contributed to their decline. Humans had to continuously adapt, moving with the land, learning new hunting techniques, and finding ways to survive in a world that was constantly changing. The diversity of human life that emerged over these millennia is reflected in the richness of archaeological sites from Alaska to Patagonia. In Alaska, evidence of hunting camps, fish traps, and stone tools shows adaptation to cold, mountainous environments. In the Great Plains, large-scale hunting of bison by coordinated groups points to sophisticated strategies for capturing and processing large animals. In the Amazon, early agricultural practices and settlements indicate that humans were able to cultivate plants and manage water, developing techniques suited to tropical forests. In the southern cone of South America, sites such as the Pampas reveal hunting of guanacos and other native animals, showing that even in grasslands humans developed specialized strategies for survival. Across this vast continent, the story of the first peoples is a story of continuous innovation, adaptation, and resilience, shaped by the interplay between human ingenuity and the natural world. Survival required more than just tools and knowledge. It demanded social cohesion, careful planning, and the ability to learn from the environment. Hunting large animals often involved coordinated strategies, sometimes over several days, where hunters would drive herds into traps or ambush points. The processing of these animals required careful division of labor, with groups working together to prepare hides for clothing, bones for tools, and meat for immediate consumption or storage. Seasonal movements allowed groups to take advantage of different resources at different times of the year, following berries, migrating birds, or fish runs, while also ensuring that populations did not overexploit a single area. Knowledge of fire, shelter construction, and food preservation was passed down orally, forming an invisible map of survival skills that guided generations across vast, unknown lands. Interactions with animals were central to human life, not only as sources of food, but as part of a larger understanding of the ecosystem. Early humans observed behavior patterns, migration routes, and seasonal cycles, allowing them to anticipate the movements of herds or the breeding habits of fish and birds. They learned which plants were safe to eat, which were poisonous, and how to store or prepare them for later use. They adapted clothing and shelter to different climates, creating insulated garments from animal hides in the north or lightweight coverings in tropical regions. Even the sounds, tracks, and signs of predators were studied carefully, forming a body of knowledge that was essential for both hunting and avoiding danger. The first peoples also carried cultural and symbolic practices that can be glimpsed in cave art, carvings, and personal adornments. In some regions, rocks were painted with pigments, depicting animals, humans, or abstract designs. Beads and ornaments made from shells, bones, and stones suggest a sense of beauty, identity, and perhaps social status. Rituals and ceremonies, though difficult to fully reconstruct, were likely intertwined with daily life, hunting, and the cycles of nature. Storytelling would have been a crucial means of transmitting knowledge, history, and beliefs, connecting generations across time and space. These cultural practices demonstrate that survival was intertwined with imagination, memory, and the desire to understand and shape the world around them. The arrival and spread of humans into the Americas had profound implications for both people and the landscapes they entered. As hunters and gatherers moved into new regions, they altered ecosystems, sometimes contributing to the decline of large animals or the expansion of certain plants through selective harvesting. Fire may have been used deliberately to manage landscapes, clear undergrowth, or encourage the growth of particular species. The interaction between humans and the environment was not one-sided. People adapted to the land, learned to read the rhythms of the seasons, and developed technologies suited to local conditions. Over thousands of years, these interactions shaped both culture and ecology, creating the foundations for the societies that would later emerge across the continents. Across the vast stretches of North, Central, and South America, the patterns of human migration continued to evolve. Some groups moved along river valleys, using canoes or rafts to navigate waterways. Others traveled across mountains, using passes and observing snow and weather patterns to guide their way. Seasonal camps gave way to more permanent settlements in some regions, particularly where agriculture began to supplement hunting and gathering. Knowledge of domesticated plants, fire management, and irrigation emerged gradually, reflecting a long-term process of experimentation, observation, and adaptation. The evidence of early cultivation can be seen in sites across Mexico and the Andes, where people began to grow maize, beans, squash, and potatoes, slowly transforming the landscapes they inhabited. Even as agriculture developed, hunting and gathering remained crucial to survival, providing protein, variety, and security against crop failure. Large-scale hunting required coordination, knowledge of animal behavior, and careful use of tools. Fishing, both in rivers and along coasts, demanded different techniques and equipment, such as nets, hooks, and weirs. Gathering plants required intimate knowledge of the land, including the timing of fruiting, the location of edible roots, and the methods for processing seeds. The ability to combine multiple sources of food, to move seasonally or in response to environmental change, and to share resources within groups was essential to enduring life across such a vast and varied continent. The first peoples of the Americas also faced challenges from the unpredictable forces of nature. Floods, droughts, volcanic eruptions, and extreme cold tested their adaptability and ingenuity. Survival depended not only on physical skills but also on observation, patience, and the capacity to learn from experience. Seasonal cycles shaped movement patterns, hunting strategies, and social structures, creating rhythms that connected human life to the natural world. The long-term interaction between people and environment forged a deep understanding of landscapes, climate, and animal behavior, forming a foundation for future societies. As populations spread and diversified, cultural differences began to emerge. Distinct languages, tool styles, and artistic expressions can be traced across different regions, reflecting the variety of experiences and adaptations developed over thousands of years. Coastal peoples had access to abundant marine resources and developed fishing technologies, while inland groups focused on large game hunting, plant cultivation, and the management of forests and plains. In the south, people in the Andes adapted to high-altitude conditions, while those in tropical lowlands developed techniques suited to rainforest environments. Each adaptation was a response to local conditions, a demonstration of human ingenuity, and a record of continuous learning and experimentation. The journey of the first peoples into the Americas is also a story of resilience. From the frozen landscapes of Alaska to the tropical forests of Brazil, from the plains of the central United States to the mountains of the Andes, humans carved a life for themselves, responding to challenges with tools, knowledge, and cooperation. They learned to move with herds, to cultivate crops, to fish, to hunt, and to build shelters that could withstand harsh weather. They communicated, traded, and shared ideas, creating networks that spanned thousands of miles. They observed, experimented, and adapted, leaving behind evidence in stone, bone, pigment, and plant remains, traces that allow us to glimpse their lives thousands of years later. This story is ongoing in its exploration, as new discoveries continue to reshape our understanding. Sites from Alaska to Chile, from the Great Plains to the Amazon, reveal different aspects of early human life, showing both shared strategies and unique adaptations. Each stone tool, each hearth, each trace of habitation adds a piece to the intricate puzzle of how humans entered and survived in the Americas. As research advances, the timelines, roots, and behaviors of these first peoples become clearer, yet the vastness of the continent ensures that countless stories remain hidden, waiting beneath layers of soil, ice, and time. The first peoples of the Americas left a legacy of adaptation, observation, and ingenuity, carried in their tools, their settlements, and their knowledge of the land. From the frozen north to the southern tip of South America, they moved, survived, and thrived in landscapes both challenging and abundant, following animals, rivers, and seasons, learning from each environment and from each other. Their lives were shaped by movement, by the need to adapt, and by a constant dialogue with the natural world, a story written in stone, bone, and soil, still unfolding as discoveries continue to illuminate the vast human journey across this continent. Their story is woven with the rhythms of nature, the patterns of animals, the cycles of rivers and seasons, and the ever-changing landscapes sculpted by glaciers, volcanoes, and shifting climates. They moved across vast plains, climbed mountains, navigated rivers, and followed coastlines, carrying knowledge, skills, and tools that allowed them to survive and flourish. Every campsite, every hunting ground, every fishing site was part of a larger network of movement and survival, connecting people across thousands of miles, and in each action, from shaping a spear point to tracking a herd, from harvesting a plant to creating a shelter, the first peoples of the Americas left traces of intelligence, creativity, and resilience that continue to inspire curiosity and research today. They crossed rivers, sometimes waded through ice-cold waters, and climbed passes over mountains, learning from every challenge. They developed strategies for hunting large animals that were much stronger than themselves, observed the cycles of the moon and the sun to guide planting or movement, and found ways to store food for the harsh winters. Their knowledge of fire, shelter, and tool-making was passed down orally, and stories became maps of survival, containing lessons about animals, weather, and landscapes. Communities shared resources and skills, supporting each other in a world full of uncertainty, showing that survival depended not only on individual skill, but on cooperation and shared understanding. Over thousands of years, this movement and adaptation led to the development of countless distinct cultures across the Americas. Coastal peoples used fish and shellfish, forests provided nuts, fruits, and game, plains offered bison and deer, and mountains supplied stone, wood, and medicinal plants. Agricultural practices began to complement hunting and gathering, leading to more permanent settlements and experimentation with plant domestication. Social structures became more complex as groups developed systems for resource sharing, tool production, and knowledge transfer. Art, symbolism, and rituals reflected not only survival, but also human curiosity, creativity, and the need for expression. From the first steps across the icy expanses of Beringia to the settlements in southern Chile, the early human journey in the Americas was marked by movement, adaptation, and ingenuity. Each generation built on the knowledge of the previous, learning from the land, the animals, and the seasons. They shaped the environment even as it shaped them, leaving traces that endure in archaeological sites, fossils, and artifacts. The story of the first peoples is a story of continuous exploration, survival, and interaction with a vast and diverse continent, a story that grows richer with each new discovery and deeper understanding. The first peoples travelled through ice, snow, rivers, and forests, always learning and adapting. They observed animal tracks, weather patterns, and the growth of plants to guide their movements and survival strategies. They developed clothing and shelters suited to extreme cold or dense forest conditions, shared knowledge through oral traditions, and created tools to hunt, process, and prepare food. Fire provided warmth, light, and a means to cook, while stone tools allowed for cutting, scraping, and shaping materials. Coordination and cooperation within groups allowed for hunting of large animals, construction of temporary camps, and protection from predators. These skills and strategies evolved over thousands of years, shaping the spread of humans across the continent. The interaction with the environment involved more than survival. People adapted to each region's particular challenges, from the high Andes to the tropical Amazon, from the Arctic North to the plains and deserts of North America. Knowledge of rivers, forests, and plains allowed early humans to find food, water, and shelter. They understood which plants could be eaten or stored, how to trap or track animals, and how to anticipate seasonal changes. They developed tools, clothing, and shelter to manage both heat and cold, wet and dry conditions. Coordination in hunting, processing, and resource sharing created networks that enabled survival over vast distances. The diversity of environments led to the diversity of human adaptation, culture, and technology. Coastal groups developed fishing tools, inland groups mastered hunting and plant gathering, and highland groups adapted to low oxygen and cold temperatures. The migration was not a single path, but a series of movements influenced by seasons, animals, climate changes, and human competition. Knowledge was shared across groups, and long-distance connections allowed the exchange of tools, ideas, and cultural practices. Symbolic artifacts reveal a rich mental and cultural life, showing that survival and creativity went hand in hand. The lands of the south of what is now called the Americas held within them stories that stretched across centuries, stories carved in stone, sung in the wind, and written in the stars. In the dense jungles of Central America, in the high plateaus of what is now Mexico, and along the winding rivers and towering mountains of the Andes, people gathered, built, farmed, and dreamed. These lands, alive with the pulse of rivers and the whisper of forests, became the stage for civilizations whose power and artistry would leave marks that still echo today. Among these were the Maya, the Aztec, and the Inca, each rising in different times and in different places, yet each weaving together culture, knowledge, and ambition in ways that astonish those who study them now. Their stories begin not with kings or armies, but with people learning to live in harmony with their lands, to grow food where soil was scarce, to read the skies, and to understand the rhythms of life and death that shaped every moment of their days. The Maya were among the earliest to rise, settling in lands that stretched across what is today southeastern Mexico, all of Guatemala, Belize, and parts of Honduras and El Salvador. They were people of the forests and the rivers, and they learned early to turn their challenging environment into a place of abundance. Maize, or corn, became their lifeline. They developed techniques of farming that allowed them to grow it on terraces and in swamps, draining water where it could be dangerous and redirecting it where it could nourish life. The soil of the lowlands was often poor, yet they found ways to make it fruitful, combining layers of natural fertilizers and creating raised fields that could survive floods. Their villages grew into towns, and towns became cities with plazas, palaces, temples, and observatories. Cities like Tikal, Copan, and Palenque became centers not only of trade and agriculture, but also of knowledge and artistry. The Maya became careful observers of the stars, tracking the movements of the sun, moon, and planets, with instruments no taller than a person but precise enough to mark centuries. Their calendars, intricate and sophisticated, measured both the passage of the year and cycles far beyond a human lifetime. They inscribed their knowledge onto stone monuments and in codices made from bark, preserving records of rulers, ceremonies, and celestial events. Their writing system, composed of glyphs, recorded history in a language that scholars today continue to decipher, revealing tales of triumph, conquest, marriage alliances, and the cycles of gods and humans intertwined. Their cities were often arranged to reflect their understanding of the cosmos. Temples were aligned to the movement of the sun and planets, and ceremonial plazas marked the paths of the heavens. The Maya believed that the world was layered, with the heavens above, the earth in the middle and the underworld below, and each layer held its own powers and spirits. Kings were seen as mediators between these realms, tasked with performing rituals, sacrifices, and ceremonies that would maintain the balance of life. These rulers wore elaborate costumes adorned with jade, feathers, and gold, while priests recorded omens and events that shaped decisions from war to harvests. They created vast networks of trade, linking jade from the highlands, obsidian from volcanic regions, and cacao from tropical forests. Markets bustled with the exchange of pottery, textiles, and food, and long roads carved through forests and hills carried not only goods but also ideas, songs, and stories. As centuries passed, the Maya civilization went through periods of great growth and periods of decline. Some cities were abandoned, perhaps because of droughts or overuse of the land, while others continued to flourish. Even when political centers fell, the knowledge, culture, and people persisted, spreading influence across the region. The echoes of the Maya can still be felt today in the languages, traditions, and ruins that dot the landscape, in pyramids that climb toward the sky, and in observatories that mark the dance of the planets. Further north, in the highlands of central Mexico, the Aztec rose centuries later, building their empire on lakes, mountains, and valleys. Around the early 14th century, in one of the most remarkable feats of engineering, they founded their capital city of Tenochtitlan on an island in the middle of Lake Texcoco. The city seemed to float on water, with canals threading between streets and chinampas, or floating gardens that grew maize, beans, squash, and other crops to feed the growing population. The Aztec learned to tame the lake, building causeways, bridges, and aqueducts that carried water and connected neighborhoods, making their city not only a center of trade but a marvel of urban design. It became one of the largest cities in the world of its time, with temples, palaces, markets, and public spaces that reflected the power and organization of the state. The Aztec society was structured around warfare, tribute, and religious devotion. Rulers commanded armies, expanded territory, and collected tribute from conquered regions. These offerings of food, precious stones, and crafted goods were stored in enormous warehouses and distributed according to need, helping sustain the empire and maintain loyalty among its people. The Aztec had a rich mythology and religious life that permeated every aspect of daily existence. The great Templo Mayor in Tenochtitlan, towering with twin temples to the gods of war and rain, was the site of rituals that included offerings, ceremonies, and sacrifices, reflecting the belief that human life itself nourished the gods and maintained cosmic balance. Priests studied the heavens and recorded events in codices, which were brightly illustrated with colours made from minerals and plants. They tracked eclipses, planetary movements, and seasonal changes, using this knowledge to determine the timing of planting, harvest, and ceremonies. The markets of Tenochtitlan were alive with colour and sound. Merchants brought goods from across Mesoamerica, including cocoa, cotton textiles, pottery, jade, feathers, and obsidian knives. The city thrummed with life as farmers, craftsmen, warriors, and priests went about their daily work, their lives intertwined by the demands of survival, devotion, and duty to the state. Social life was complex, with noble families holding power, artisans crafting beautiful objects, and commoners tending fields, raising children, and participating in local rituals. Education was valued, with schools for children of the elite and common people teaching history, law, and religion. Storytelling and song preserved the history of kings and heroes, passed down through generations so that the memory of deeds and decisions remained alive. While the Aztec Empire spread its influence through central Mexico, farther south along the western edge of South America, a different civilization was taking shape in the towering Andes Mountains. The Inca rose on high plateaus, stretching from what is today southern Colombia to central Chile, ruling an empire connected by mountains, rivers, and deserts. Their center, Cusco, became a hub from which roads radiated across tens of thousands of kilometers, linking remote villages, farms, and mining centers. The Inca learned to cultivate steep slopes, building terraces that captured rainwater, reduced erosion, and provided microclimates suitable for potatoes, maize, quinoa, and other crops. They raised llamas and alpacas, not only as food but as beasts of burden and sources of wool, weaving fibers into textiles of extraordinary quality. The Inca were masters of organization and administration. They divided their lands into units, with appointed leaders responsible for collecting taxes, coordinating labor, and overseeing agriculture. Roads, often paved with stones, carved through mountains, connected distant parts of the empire, allowing messengers known as chasqui to deliver messages, goods, and information with incredible speed. Bridges of rope and stone spanned valleys, rivers and gorges, enabling armies, traders, and officials to move across otherwise impassable terrain. The architecture of the Inca reflected their understanding of both the land and the forces of nature. Temples, palaces, and fortresses were built with enormous stones, fitted together without mortar, shaped precisely to withstand earthquakes and to endure centuries of weathering. Machu Picchu, perched on a ridge high above the Urubamba River, remains one of the most striking examples of their skill, blending seamlessly with the natural contours of the mountain. Religion for the Inca was intimately tied to the land and the sun. The Sapa Inca, considered the descendant of the sun god Inti, ruled as both a political and religious leader, responsible for maintaining the harmony between the people, the land, and the spirits. Rituals, offerings, and festivals mark the passage of time and the cycles of nature. Ceremonies honored the sun, the mountains, the water, and the fertility of the earth. Priests maintained knowledge of astronomy, agriculture, and medicine, guiding farmers and rulers alike. Records were kept not in writing but in knotted strings called quipus, encoding numbers, resources, and events in patterns of knots and colours, a system that carried information across the vast empire with surprising accuracy. Trade and communication connected the empire internally and with neighbouring peoples. Llamas transported goods, and roads allowed armies to move to defend the empire or to expand its reach. Markets brought together food, textiles, metals, and other products, while artisans created jewellery, pottery, and textiles reflecting both everyday life and spiritual beliefs. The Inca adapted to the varied climates of the Andes, from high snow-capped peaks to lower valleys, ensuring that the people could survive and thrive in lands that could seem harsh or inhospitable. All three of these civilizations, Maya, Aztec, and Inca, shared a dedication to understanding the world around them, though each did so in its own way. The Maya mapped the heavens and carved calendars in stone, the Aztec built cities on lakes with canals and aqueducts, and the Inca carved roads and terraces into the mountains. Each civilization developed systems of governance, agriculture, and religion that responded to the environment and human needs. They built monumental architecture, recorded history and knowledge in writing or quipus, and created art that expressed spiritual, social, and political life. They thrived in regions that demanded ingenuity and cooperation, and their achievements demonstrate the remarkable capacity of human societies to adapt, organize, and imagine futures far beyond the present. In addition to architecture, agriculture, and governance, each civilization developed art and craft that reflected both daily life and spiritual beliefs. The Maya sculpted stone stelae and painted murals depicting kings, gods, and ceremonies. They created intricate jade jewelry and pottery that combined beauty with symbolism. The Aztec produced codices filled with pictorial writing, carved sculptures, and featherwork that adorned clothing and ceremonial objects. They painted murals that told stories of gods, warriors, and cosmology, often using vibrant colours derived from minerals and plants. The Inca wove textiles with complex geometric patterns and dyed colours, created gold and silver jewellery that honoured deities and ancestors, and built pottery that served both practical and ceremonial purposes. Each culture expressed identity and belief through material objects that were both functional and symbolic, bridging the sacred and the everyday. The landscapes these civilizations inhabited were not merely backdrops, but active participants in the shaping of culture. Rainforests, lakes, rivers, mountains, and valleys influenced settlement patterns, agricultural techniques, and religious beliefs. The Maya read the cycles of rainfall and drought, adjusting planting and ceremonial schedules to match. The Aztec adapted to a city built on a lake, creating floating gardens, aqueducts, and canals. The Inca contended with steep slopes and varying climates, terracing fields and constructing roads to unite their empire. Their relationship with the environment required observation, experimentation, and long-term planning, as survival depended on both human skill and natural cycles. Each civilization also understood and exploited trade and communication to strengthen their societies. Trade routes carried goods, ideas, and technologies, connecting regions and fostering economic and cultural exchange. Markets were centers of social life as well as commerce, where merchants, farmers, artisans, and travelers interacted, sharing stories, goods, and innovations. Diplomacy, alliances, and tribute systems allowed rulers to maintain influence and integrate diverse peoples under their control. The movement of goods such as cacao, maize, textiles, obsidian, jade, and metals linked distant regions, creating networks of interdependence that supported both the economy and the state. Knowledge of astronomy and mathematics underpinned the planning, construction, and religious practices of all three civilizations. The Maya tracked solar and lunar cycles and predicted eclipses, aligning temples and pyramids with celestial events. The Aztec used calendars to schedule religious festivals, agricultural cycles, and political decisions. The Inca observed the sun and stars to determine planting times, festival dates, and religious observances, linking the movement of celestial bodies to the rhythm of life on Earth. These observations were not abstract. They directly influenced farming, ritual, and the organization of cities and roads. Warfare played a role in both expansion and internal cohesion. The Maya engaged in conflicts between city-states, competing for resources, prestige, and tribute. The Aztec waged wars that expanded their empire and secured tribute, while the Inca integrated newly conquered peoples through both diplomacy and force, maintaining control across vast and challenging landscapes. These military endeavors were tied to religious beliefs, political necessity, and economic interests, influencing the structure of society, leadership, and the distribution of resources. Life in these civilizations was also deeply connected to the cycles of birth, life, death, and the spiritual world. Rituals marked the passage from childhood to adulthood, marriage, and death. Festivals and ceremonies honored gods and ancestors, bringing the community together in celebration and remembrance. Storytelling, song, and dance preserved history and past knowledge across generations, ensuring that the lessons of the past remained alive in the present. Education for young people involved learning skills for survival, craft, leadership, and religious observance, fostering a sense of duty, identity, and connection to the wider world. Despite the differences in time, location, and society, the Maya, Aztec, and Inca demonstrate how human beings have repeatedly turned challenging landscapes into centers of creativity, governance, and culture. They show how people have observed the natural world, harnessed its resources, and connected communities over distances that would seem insurmountable. They reveal how spirituality, art, science, and social organization intertwine to create civilizations capable of leaving lasting marks on the land, on culture, and on human memory. Each civilization adapted to its surroundings, learned from the past, and innovated for the future, producing societies whose echoes are still visible in the ruins, languages, traditions, and stories that continue to survive in the present. Their stories are not static. They continue to be uncovered, interpreted, and felt. Archaeological discoveries reveal new aspects of daily life, religious practice, and governance. Stone carvings, ceramics, textiles, and agricultural terraces speak across centuries. Researchers study the alignment of temples with the sun, the structure of roads and canals, the organization of markets, and the complexity of social hierarchies. Modern descendants preserve languages, rituals, and crafts that trace their roots to these ancient civilizations, creating continuity that spans centuries and geographic change. The ingenuity of the Maya, Aztec, and Inca reflects the deep human capacity to understand, shape, and thrive in diverse environments. The forests, lakes, and mountains were not merely obstacles. They were opportunities for innovation, creativity, and social cohesion. People developed techniques to farm steep slopes, control flooding, build monumental structures, organize vast populations, and interpret the cosmos, all while expressing beauty, faith, and identity in art, ritual, and architecture. These achievements reveal a complex interplay between environment, human skill, and imagination, showing how societies grow, adapt, and flourish in response to both opportunity and challenge. Their languages, records, and monuments are keys to understanding how they saw the world, how they governed, how they worshipped, and how they sustained life across centuries. The interplay of trade, war, religion, and agriculture shaped patterns of growth, stability, and cultural richness. As their cities rose and fell, as dynasties came and went, and as landscapes were transformed, the influence of these civilizations extended beyond their own borders and time, leaving traces that continue to intrigue, inspire, and inform. Even the architecture demonstrates a relationship with both humans and nature. Maya pyramids rise from forested floors as if grown from the earth, Aztec temples punctuate the shimmering waters of a vast lake, and Inca fortresses cling to cliffs overlooking valleys and rivers. Roads, terraces, canals, and markets reveal the interweaving of engineering, agriculture, and social organization. Artistic creations, from codices to carvings to textiles, embody both functional and spiritual concerns, blending utility with expression. Knowledge of seasons, rainfall, and celestial cycles influenced agriculture, ceremony, and planning, connecting practical survival with cultural continuity. The arts of the Maya, Aztec, and Inca continue to influence and captivate. Sculptures, murals, textiles, jewelry, and ceramics reveal not only aesthetic skill, but also complex symbolism, religious devotion, and social hierarchy. Colors, patterns, and forms carried meaning, conveying status, spiritual beliefs, and historical events. Music, dance, and storytelling enriched daily life and ritual, reinforcing identity, cohesion, and memory. These forms of expression were intertwined with the rhythms of work, worship, and communal life, creating a tapestry of culture that linked past and present, human and environment, sacred and mundane. Across centuries, the rise and adaptation of the Maya, Aztec, and Inca demonstrate the diversity of human experience in the Americas. Mountains, lakes, rivers, and forests shape the choices, technologies, and societies of these civilizations. People transform landscapes into fertile fields, bustling cities, and monumental architecture, adapting techniques that suited their environment and needs. Social organization, religious belief, and scientific observation guided daily life, ceremonies, and statecraft. Trade, communication, and warfare connected people across regions, while art, writing, and ritual preserved memory and identity. Knowledge passed from one generation to another, ensuring that even in times of change, culture and skill continued to flourish, leaving traces that survive in ruins, traditions, languages, and practices today. From the jungle temples of the Maya to the floating gardens of the Aztec to the terraces of the Inca, human ingenuity reshaped landscapes and societies, blending survival, belief, and artistry. Their achievements reflect the interplay of environment, resourcefulness, organization, and imagination, revealing civilizations capable of extraordinary adaptation, creativity, and endurance. In examining their roads, pyramids, codices, textiles, and temples, the traces of human thought, labor, and faith are visible, marking a history that continues to unfold through study, exploration, and the living traditions of descendants. Across the Americas, the echoes of these civilizations remind us of the ways people have risen in the face of environmental challenges, harnessed natural resources, and created cultures of immense depth, complexity, and beauty. They demonstrate how humans have built cities, cultivated crops, governed diverse populations, and interpreted the heavens. They offer insights into the connection between humans and the land, the spiritual and the practical, the individual and the community. Even today, ruins, artifacts, and cultural practices preserve memory and identity, allowing the achievements of the Maya, Aztec, and Inca to continue to inspire curiosity, admiration, and exploration of the past. These civilizations show the weaving together of knowledge, labor, faith, and creativity, producing societies that adapted to rivers, lakes, mountains, and forests. They organized states, collected tribute, engaged in trade, and conducted ceremonies. They studied the skies, recorded events, and preserved memory in stone, bark, or knotted strings. They sculpted, painted, and wove, creating beauty that reflected both everyday life and spiritual belief.